Lions are, without a doubt, one of the most culturally and scientifically significant animals alive today, and the extinct cave lions were undoubtedly no different along the frigid prehistoric steppe of Eurasia and North America, as evidenced by cave paintings and figurines, along with them being one of the Ice Age's top predators. But how far did this connection and correlation between modern lions and cave lions go? While well known within the fossil record and are a recognizable species among the Ice Age paleobiota, the taxonomic position of cave lions wasn't always concrete. Setting aside the fact that both Eurasian species and the American lion are sometimes grouped together as subspecies of the same animal, with a plethora of other subspecies grouped with them, it has also been debated as to whether cave lions were a unique cold-adapted paleo-subspecies of the modern lion, or a distinct lion-adjacent species that is at most closely related to the extant lions. I'm saying lions a lot. Thanks to a recent study, we may now have a more proper understanding of the cave lion's placement within the big cat lineage. Simply put, they were not actual lions. They are lions in name only, but are genetically a separate species of big cat altogether. We know this thanks to analysis of both mitochondrial and nuclear DNA of the animals, and with this analysis, we also learned that both big cats diverged from each other anywhere from 1.9 million to 500,000 years ago, which is slightly more recent than the divergence between lions and leopards, though ultimately the latter divergence isn't all that definitive in its timing at this current moment. Following this divergence, the subject of interbreeding between cave lions and modern lions has also long been the subject of debate. But now we have more clear evidence that at certain points in the late Pleistocene, their ranges not only overlapped, but the two species did indeed interbreed. In general, cave lions and extant lions occupied differing regions. Eurasian cave lions were spread from the Iberian Peninsula and the British Isles to Siberia, North China, and Japan, and even dispersed into Alaska and northern Canada, eventually giving rise to the American lion farther south. While only found in India today, Asiatic lions were once found across West and Central Asia, with Holocene records in southeastern Europe, having first crossed into the supercontinent around 64,000 years ago. Because of these brief overlaps, some Asian cave lion remains, particularly those dating from 60 to 20,000 years ago, were found to have anywhere from 3.2 to 4.4% of lion DNA, inherited no doubt from Asiatic lions that have since disappeared from West Central Asia. Glacial cycles may have also helped in such interactions. While cave lions were well accustomed to living in the cold stretches of the Mammoth Steppe, they did not exclusively inhabit those biomes, and expanding glaciers may have limited their distribution in the high north and forced them farther south, allowing them to cross paths with Asiatic lions. Additionally, more information has been gathered regarding region-specific cave lion genetics. The earliest European remains are found to be the most, ancient, until they were replaced by populations of more recent Siberian ancestry after disappearing during the last glacial maximum in a similar vein to cave bears and European cave hyenas, while the Eastern Beringian or North American remains have been found to possess some genetic admixture which is speculated to have been potentially from crossbreeding with the American lion. Given that a 67,000-year-old fossil was found in the Yukon recently, this makes overlap between the two species even more possible. But this is not set in stone, as further analysis on the American lion's genetics is needed to properly confirm this. And while we are aware that interbreeding most commonly occurred somewhere along Central Asia, there is also the possibility of such interactions even happening in Europe, but we need further DNA analysis to properly confirm this. What's especially ironic to me about all of this is how cave lions went through a similar phenomenon to two other carnivorans that were common in Ice Age Eurasia. For starters, the cave bear, a species that cave lions are known to have hunted. With less than stellar success rates, judging by all the mangled adult remains found in various cave sites, has been found to have crossbred with modern brown bears during the Pleistocene, with a small percentage of living brown bears carrying cave bear DNA the same way how a small population of humans carry Neanderthal DNA to this very day. And then there are the wolves, a species still found in both Eurasia and North America, and one that has recently been cited as one of the potential reasons for the cave lion's extinction, has a genetic history that greatly parallels the cave lion, from ancient European populations being replaced by those of Siberian ancestry, to North American populations interbreeding with other canids like coyotes and red wolves. The paper even acknowledges the very clear parallel between the two predators. And speaking as someone who's deeply fascinated by cave lions, I have to say this has been an especially great year in terms of research and our understanding of this species. From confirmation of their presence in Japan, to another paper covering their depictions in cave art, and now not only evidence of interbreeding with our modern lions, but further credence to their placement in the big cat family tree as their own separate species. This is honestly making me more excited for future studies and furthering our understanding of this Ice Age relic.